Crash course on philosophy of science, scientific method and inquiry. Learn about the scientific method and the principles of scientific inquiry. Certainly. Philosophy of science is a fascinating topic that explores how scientific knowledge is acquired, verified, and applied in the real world. It delves into the principles and assumptions underlying scientific research and helps us understand how science is different from other forms of knowledge. One of the most essential concepts in philosophy of science is the scientific method. It is a systematic way of investigating phenomena in the natural world, and it involves a series of steps that are used to collect data, test hypotheses, and draw conclusions. Although the scientific method has evolved over time, it generally includes the following steps. 1. Observation. Scientists observe and gather information about a particular phenomenon or event. This may involve using instruments, collecting data from surveys or experiments, or examining existing records. 2. Hypothesis. Based on the observations, scientists formulate a tentative explanation or prediction about how the phenomenon works or what causes it. This explanation is called a hypothesis. 3. Prediction. A hypothesis is tested by making predictions about what should happen in other situations. For example, if a hypothesis suggests that a new drug will cure a particular disease, a prediction could be made that patients who receive the drug will experience fewer symptoms than those who do not. 4. Experimentation. To test the hypothesis, scientists conduct controlled experiments that manipulate one or more variables and observe the outcomes. This helps to determine whether the hypothesis is supported by the evidence. 5. Analysis. The data collected from the experiment are analyzed to determine whether they support the hypothesis or not. If the hypothesis is not supported, it may be revised or discarded. 6. Conclusion. Based on the analysis, scientists draw conclusions about the phenomenon being studied. These conclusions may support or contradict the hypothesis, or they may suggest new questions for further research. Although the scientific method is a valuable tool for understanding the natural world, it is not perfect. Scientists are human and can make mistakes or have biases that affect their research. Additionally, scientific knowledge is always tentative and subject to revision based on new evidence or discoveries. One famous example of the scientific method in action is the discovery of the structure of DNA. In the early 1950s, scientists James Watson and Francis Crick were working to determine the three-dimensional structure of DNA. They had access to data from other researchers, including Rosalind Franklin, who had used X-ray crystallography to study the molecule's structure. Using this data and their own creative insights, Watson and Crick formulated a hypothesis about the structure of DNA as a double helix. They then made predictions about how the molecule should behave under different conditions and conducted experiments to test these predictions. Ultimately, their analysis of the data supported their hypothesis, and they were able to publish their findings in the journal Nature in 1953. Now, let's take a look at the top 12 scientific method and the principles of scientific inquiry. 1. Empiricism. Scientific knowledge is based on observation and experimentation, rather than intuition or authority. 2. Objectivity. Scientists strive to be impartial and unbiased in their research and analysis. 3. Falsifiability. Hypotheses and theories must be testable and potentially falsifiable, meaning that they can be proven false by empirical evidence. 4. Replicability. Scientific findings should be reproducible by other researchers, using the same methods and data. 5. Parsimony. The simplest explanation that fits the data is usually preferred over more complex explanations. 6. Induction. Scientific knowledge is based on inductive reasoning, which involves generalizing from specific observations to form broader theories or hypotheses. 7. Deduction. Scientific hypotheses and theories are tested by making deductive predictions about specific observations or experiments. 8. Theory-ladenness. Scientists' interpretations of data are influenced by their pre-existing theories, hypotheses, and beliefs. 9. Scientific skepticism. Scientists should be skeptical of claims that are not supported by empirical evidence or logical reasoning. 10. Scientific community. Science is a collaborative enterprise, and scientific knowledge is developed through interactions among scientists from different disciplines and backgrounds. 11. Peer review. Scientific findings are evaluated by other experts in the field, who provide feedback and critique to ensure the quality and accuracy of the research. 12. Progress. Scientific knowledge is cumulative and progressive, building on previous research and discoveries to advance our understanding of the natural world. One interesting example of scientific inquiry is the study of dark matter. Scientists have long observed that the gravity in the universe appears to be stronger than can be explained by visible matter alone. To account for this discrepancy, they have hypothesized the existence of dark matter, a mysterious substance that does not interact with light and cannot be directly observed. To test this hypothesis, scientists have conducted numerous experiments using a variety of techniques, including observations of the rotation of galaxies and the cosmic microwave background radiation. While the nature of dark matter is still not fully understood, this ongoing research has helped to expand our knowledge of the universe and the laws that govern it. To summarize, the philosophy of science is a critical component of scientific research and inquiry. The scientific method provides a structured approach to investigating the natural world, and the principles of scientific inquiry help us understand the assumptions and practices that underlie scientific knowledge. By following these principles, scientists can produce reliable and useful knowledge that can be applied to a variety of practical problems and challenges. As promised, here's a poem on the topic. Inquiry and Method, the Tools of the Trade. That scientists use to study and investigate. Observation, hypothesis, and prediction. Experiments and analysis, the keys to conviction. Empiricism is the guiding light. Objectivity, the ideal we strive to cite. Falsifiability, the test we must pass. Replicability, to ensure the truth will last. Simplicity and induction, the paths we tread. Deduction and theory, to test what we've said. Theory-ladenness, a lens we can't escape. Skepticism, to keep us from making mistakes. Community and peer review, to keep us on track. Progress, the promise that we won't look back. Philosophy of science, the foundation we lay. For knowledge and understanding, come what may. Start planning your next global adventure with ease and convenience with our Booking.com referral link. https://www.booking.com/index.html. A=7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our NHub Metaverse channel, and please watch more interesting videos here.